You are welcome to my YouTube channel. Today I've brought for you some work on writing redox equations, and this is strictly A-level work. So an A-level student, you are welcome. Now in this topic I'm discussing how you write redox equations. Remember, to write a redox equation you need to understand the concept of oxidizing agent and reducing agent. I request that you watch my other video on the same reducing agent and oxidizing agent. Also watch my video on what we call calculating for the oxidation states, so that you'll understand who has been oxidized, who has been reduced. Remember, in any redox reaction, those two reactions, reduction and oxidation, cannot work isolatively. Reduction cannot occur alone. A substance is reduced by another substance, then the other substance will be oxidized. But please, before I continue, remember to hit the subscribe button and also like the video. So let's dive into this. We shall be very brief, just about 2 or 3 examples, then you'll be set to go. So let's look at the steps. How do you write a redox equation? To write a redox equation, we need to first write what we call a half equation, 2 half equations, one oxidation half equation for a substance being oxidized, then the reduction half equation for a substance being reduced. So these are the steps how to write, to balance a half equation. Then from the 2 half equations we combine them by eliminating electrons to get what we call a redox equation. Now, what are the steps in balancing a half equation and writing a redox equation? Step 1, identify the medium of the reaction. The medium can be identified from even the question. If the question said acidified, so the medium is acidic. If the question said neutral, the medium is neutral, or there is water as a medium. If the question said alkaline, then actually the medium is an alkaline medium. Now step 2, identify the products and the reactants. So look at the products and the reactants. Identify if one substance is an oxidizing agent, what does it go to? Of course, an oxidizing agent is normally reduced, while a reducing agent is normally oxidized. So look for the oxidation products and the reduction products. Step 3, balance all other atoms other than oxygen and hydrogen atoms. When you are balancing a half equation, don't try to balance anything like oxygen or hydrogen. Just balance anything except oxygen or hydrogen. Step 4, now go to balance oxygen. That's the next thing to balance before you balance hydrogen. Balance oxygen atoms by adding appropriate number of water molecules on the side deficient of oxygen. So if the side has few oxygens, put there water. The number of water molecules that brings oxygen to the same number. Step 5, balance hydrogen atoms by adding appropriate number of hydrogen ions on the side deficient of hydrogen. So after balancing oxygen atoms, remember you are using water. Water will create hydrogen atoms, so you will have to balance hydrogen atoms using hydrogen ions on the side where the hydrogen atoms are not there. Then step 6, balance the charge. So you balance the charge using electrons. If the side has a higher positive charge, it's where you add electrons to reduce the positive charge. Because electrons are negatively charged, so you can't add them where the negative charge is high. So balance charges by adding electrons on the side deficient of electrons, or on the side which is most positive. Let's dive into the first example. Now the question said we have to write an equation between acidified potassium permanganate, potassium manganate 7, and hydrogen peroxide solution. Now for this case, manganate 7 ions are going to be taken to what? And hydrogen peroxide will consequently be taken to what? So manganate 7, the highest oxidation state, is going to be reduced to manganese 2 ions. So by observation, let me start by what we call reduction half equation. So let me start with the equation for potassium permanganate. Potassium permanganate is actually this, but the manganate 7 ions are actually being converted to manganese 2 ions. So by practice, sir, how do I know that? This is known by practice, one at a time. Today you've known that manganate 7 ions go to manganese 2 ions. In the next example, you'll know something else. As you learn slowly, we now get to start learning and mastering these things. So now, if this is our reactant, this is the product, we say this, we are writing 2 half equations first, then add them together. So what do? We look at atoms which are not oxygen or hydrogen. I can see manganese is 1, manganese is 1. So manganese is balancing, don't tamper with it. So now let's go to the next step. Of course, the first step was the medium is acidic here. Acidic meaning the final equation should have hydrogen ions. The next one is identify products and reactants. I've already identified manganate 7 ions to manganese 2 ions. Then balance all other atoms other than oxygen and hydrogen. Manganese is balancing. Next, balance oxygen atoms by adding water molecules. Here there are 4 oxygen atoms. I have to add 4 water molecules there to balance oxygen atoms. So that is step 1. So step 1. So step 2, I'm adding water molecules on the right hand side. So plus 4 water molecules because I lack 4 oxygen atoms, so this creates 4 water molecules to be added there. So by doing so, hydrogens are becoming 8. So next step is balance hydrogen atoms by using hydrogen ions. So I'm going to add 8 because the other side there is 8 hydrogen atoms. So I use 8 hydrogen ions to get manganese 2 ions, then plus 4 water molecules. So that right away gives us the balance equation in terms of atoms. Now let's look at the charges. The total charge is -1 plus 8 gives us +7. So the total charge this way is +7. Total charge that side I can only say +2 here. So this is higher positive value. I have to reduce this to 2 by using 5 electrons. So 5 negatives will make this one become 2. So last step, add 5 electrons. So that gives us equation 1. Call it equation 1 as a reduction half equation. Manganate 7 has been reduced. Let's look at hydrogen peroxide. If manganate 7 has been reduced, hydrogen peroxide has to be oxidized. So hydrogen peroxide has reduced manganate 7 has oxidized it. They work together. So let's look at hydrogen peroxide oxidation half equation. So hydrogen peroxide has two behaviors in redox reactions. It is oxidized if it is being reacted with an oxidizing agent, and it is oxidized to oxygen. It is reduced to water if it is being reacted with a reducing agent. So for this manner, we are going to oxidize it to oxygen since acidified potassium manganate 7 is oxidizing agent. So it's oxidized to oxygen and reduced to water in the other reaction if it is with a reducing agent. Let's look at the equation. We see that hydrogen peroxide here has hydrogens and oxygen atoms. There are no other atoms, so we need now to balance oxygens. That's the first step. So oxygen atoms are 2, oxygen atoms are 2. So oxygens are balancing. Let's balance hydrogen. Hydrogen atoms are 2 no hydrogen atoms. So I'm going to add 2 hydrogen atoms the other side. So we shall get oxygen atoms plus 2 hydrogen ions. We use hydrogen ions. So let's look at the charges. There is no charge. This overall charge is 0. Overall charge is plus 2. So I reduce where it is a higher positive value. So next step, I'm going to add 2 electrons that side. So in first step, second step, third step. So in this step, I'm adding 2 electrons. So this equation is called equation 2. I'm going to add it to this equation. Then I'll cancel the electrons. So here there are 5 electrons, 2 electrons. So I'll multiply this by 5, multiply this by 2. So we cancel to form the redox equation by eliminating the electrons using appropriate figures or appropriate coefficients. So I'm going to bring this down. Manganate 7 plus, hope now we know I've reached here, so that one you've seen it. So I'm clearing off the unwanted equations, even this. So my wanted equation is actually this. So I'm just going to add them direct at this stage. Don't mind about the large space because I don't want to rewrite again. So this is 2 multiplied by 5. So that there are 10 electrons to be eliminated. So let's add together. 2 manganate 7 plus, this is now 16, but down here there are 10 protons. So we take the smaller protons to a side with many to subtract. So 16, they will come on the left hand side. 16 minus 10 gives us about 6. Then plus 5 hydrogen peroxide gives us 2 manganese, 2 ions, plus 8 water. Then we are adding also 5 oxygen atoms. So that's how you write the equation. Now if you wanted the observation, manganate 7 is purple, hydrogen peroxide is colorless, manganese 2 is colorless or faint pale pink, oxygen is colorless, water is colorless. So we would say purple solution turned to a colorless solution and bubbles of a colorless gas were evolved. So that gas lights a glowing splint, but that might not be important to us. So that's how you write the redox equation for that. This is now the overall redox equation. This is reduction half equation, oxidation half equation. Let's now look at the next example here. Sulfur dioxide gas was bubbled through acidified potassium dichromate 6 solution. Let's write the half equation for sulfur dioxide, then write the half equation for acidified potassium dichromate 6 solution. So sulfur dioxide, if it's sulfur dioxide or sulfur trioxide, they will all always be oxidized to a sulfate ion. So sulfur dioxide is going to be oxidized to a sulfate ion. So let's try to balance all other atoms other than oxygen and hydrogen. Sulfur is 1, sulfur is 1. So sulfur atoms are balancing. So let's look at oxygen atoms. I have 2, I have 4. So I need to add 2 water molecules this side since I need 2 oxygen atoms created here. So 2 water molecules giving us sulfate ions. So next step, I've created in hydrogen atoms, so I need 4 hydrogen ions the other side. Sulfur dioxide plus hydrogen gives us sulfate ions plus 4 hydrogen ions. Now by doing so, let's now look at the charge. I have the 0 charge, I have a charge of 4 minus 2, that's positive 2. So I have to add 2 electrons the other side to make the charge 0, because this way there is no charge. So I have this plus 4 protons plus 2 electrons, so that negative 2, negative 2, that's 4 plus this positive, you get 0. Now this is equation 1 for sulfur dioxide. Let's look at acidified potassium dichromate. So this is 1, this is 2. Potassium dichromate ions are like this. So what we are going to do, what does it go to? What is it going to? It's going to chromium 3 ions. Now we can check if you want to know whether it's oxidation or reduction, check the oxidation state here. You can calculate it. Watch my video about how you get oxidation states here. So let's type in from here. This is chromium atoms. By calculation you'll get oxidation state plus 6. So try to calculate oxidation states and compare these two. You realize that one is higher than the other. So it will have told you that this has been oxidized, this has been reduced. So let's now dive into this. Now chromium atoms are not balancing, so I need to multiply by 2 since chromium is not part of oxygen or hydrogen. So I multiply this side by 2 to balance chromium atoms, then introduce 7 water molecules the other side to balance oxygen atoms. So I'm getting 2 chromium ions plus 7 water molecules to balance oxygen atoms. So it creates 14 hydrogen atoms, so I add 14 hydrogen ions this side. So plus 14 hydrogen ions gives us 2 chromium 3 plus 7 water molecules. So let's check on the charges. This is 14 positives minus 2 gives us 12 positives, positive 12. This gives us 6 positives, positive 6. So we reduce this side with a high positive value by adding 6 electrons this side. So plus 6 electrons. So plus 6 electrons. You get 2 chromium 3 plus 7 water. So if we try now, this is now equation 2, so it's balancing. So we are going to add equation 2 to equation 1 here. So let's clear off the unwanted equations. So I clear off all this. But you don't show all these steps when you are doing an exam. This is just for illustrative purpose, for getting to be sure that what you've done is right. So you add those 2. Here there are 6 electrons, there are 2 electrons, so I multiply this by 3 to make them the same. Now let's add together. I have 3 sulfur dioxide gas. Then I have 6 water molecules. In this equation I have 7 water molecules. So I'll transfer water molecules on the right. So it will be 7 minus 6. That will be 1 water molecule. Let's solve that. Then I have 14 hydrogen ions. There are 14 but minus 12. That gives me 2 hydrogen ions. So it is 14 minus bigger minus small, so gives us this side as 3 sulfate ions plus 3 chromium ions, then plus 7 water molecules, but they became 7 minus 6. This is 1 water molecule. So that's the equation. You can check all through. Sulfur is 3, sulfur is 3. You can check oxygen is 6, oxygen. Hope that's balanced. I've forgotten the dichromate ions here. So let's add them there. 3 sulfur dioxide gas plus dichromate 7 ions plus 2 hydrogen ions gives us that side. So if you check the oxygen atoms, that is 6 oxygen plus 7, that gives us 13. So this is 12 plus 1, 13. So that's how now you balance what we call the half equations, from which you add the half equations to get the redox equation. Thank you for watching. Endeavor to go and watch my videos on oxidation state, reduction, reducing agent, oxidizing agent, redox reactions. Thank you for watching. See you in the next video.